So we'll see first what is this link. Okay, so linking files. So two type of links are there, soft link and hard link. Okay, link means it is a link to one file to other file. The links we have a two type, soft link and hard link. To link files, it allows multiple file names to be associated with the same file. We can assign a new name for an existing file. The file can be accessed by both the names. Okay, so we can take this one. Okay, so we'll take directly. Okay. Okay. Link files, it allow multiple file names to be associated with a single file. Means we are not changing the file name. Just there is a multiple names are there for a same file. Okay. So for example, this is the file and this is same file only, but with a different names. Different kind of stuff is also there. So there is a no difference between soft link and hard link, and how to create a soft link and hard link we can see. Soft link file. So one second, we need a paintbrush for explaining. Look at here. I have a file. My file name is original file. This is main file, original file. Now I created a soft link file. The file name is soft link file. Okay. And also I created a hard link file. Okay. Also I'm creating hard link file. Links, two types are there, soft link file, another one is a hard link file. Okay, hard link file is there. So what is this files are created? So for example, my original file is OF1. Okay, O file 1. Original file is name is O file 1. Soft link file is S file 1. And hard link file is H file 1. Only. Now, what are the data in the O file 1? So for example, in O file 1, I have a 3 lines are there. These 3 lines also visible from S file 1. I put a cat O file 1. The data will be shows. Same data shows in S file 1, in H file 1. Meaning is these 3 files contains same data. You can able to see same data. O file 1, S file 1, H file 1 contains same data. Okay. So if you add a line, I am added one line here. Same line will be shows here. Okay. If I add a line here, same line will be added here also. Okay. Same line we can able to see from here also. So that is original file, soft link file, hard link file. So whatever it is, data is the same. We can able to see the data, view the data, modify the data from original file, soft link file and hard link file. So data content is same. Okay. Little differences are there. So this is first one. So as the same. Second. Okay, one by one you have to check the differences. Second one. Second one is, okay, the second one is size of the file. For example, this is 10K file. The file size is 10K. This is 6K. This is 10K. Original file and hard link files size is same. Softlink file is a constant size. Okay, for example, here 2K is added, extra one line is added, size is now it is 12K. This is also 2K will be added and it become 12K. But this is still 6K only. Still 6K only. So again, what I'm trying to say is size of the original file changes. Hard link file will be changes, but soft link file no changes. Same file size both will maintain. Okay, hard link and soft link same files. Okay, original file, soft link file, and hard link file. So original file, what are the content of original file? Same content in a soft link file and hard link file. Okay, soft link file is more like a shortcut type. It's like a shortcut type. Okay, what is shortcut? For example, you can see I have a data on my screen, right? So this is a shortcut. This is shortcut. This is a shortcut. It's a folder. You can see shortcut folder. If I open this shortcut folder, there is a data, but data shows in the F drive very soft folder. But actually the folder is there in my desktop. It looks like a C drive. It is a C drive. Okay, but shortcut to the F drive folder. Original data contains in the F drive only, but I can able to access from here, from there also. Same thing is shortcut file means you can access the data from here and you can data from here, but original data stores here only. Second, hard link file is like a duplicate file. It's a kind of link but duplicate. Okay, so link but duplicate is means size of the original file, data is in original file as well as hard link file. Data in the original file as well as hard link file. Both contain same data. Not just shortcut, it is both contains same data. Both contains same data. Okay. If you your original file increases, soft link file size is also increases. So keep it that way. Okay. So there is a few more differences are there. So look like here it is. I took a original file. Its name is wo-file1. Soft link file is sfile1. Hard link file is h1. Just any name you can take it just for understanding. I'm taking like this. Okay. Now I created a original file. First I have to create a original file. Then I will create a soft link file. Then I will create a soft link file. So how to create a soft link file? First of all, I have to create a original file, right? So I put a wo-file1. Here this is original file. I created a original file. File name I created. Next, again verify the data. Soft link file. Now I'm creating soft link file. Guys, remember file should not be exist earlier. Okay, it should be a fresh file. So like this, by creating only we'll create ln space -s ln space hyphen s space o file 1 space s file 1. Okay, s file 1 I didn't create it earlier. Now it will be created. Next, I want to create a hard link file now only. Later I will check the differences. I want to create a hard link file now only. Later you can check the differences. H o file 1 H file 1. Okay, o file 1 H file 1. So this is the original file and hard link file will be created. So now it is created. Now one by one. Cat o file 1 cat s file 1 cat h file 1. Everything having same data or not. Next, cat greater s file 1. Add something like this is no double greater. This is s file 1 file, or you can put it's a soft link file. A soft link file completed. Then cat o file 1 cat h file 1. So there you will find these two lines, this line and as well as this line. You can able to see it. Same cat double greater h file 1. Now you can put it. So this is h file 1 file, which is hard link file. Now again cat o file 1 at h file 1 cat s file 1. Okay. So this is compulsory. Check it. And one more I forget, that is once you are created these things, once you are created, look at here, ls space hyphen l question mark file 1, because question mark means single character. O, S, H, G, three things will come up. Okay, including G file 1 is also there, right? So like that. So we will see, we can see the details here. Can specific details are there, so you have to compulsory check the details, both compulsory size kind of stuff also. I including I, so use like this. So then I will show you what are the same, what is the difference. Same thing after this one also. ls space hyphen il question mark file 1. Okay, like this. Okay. Okay, so we'll try and I will show you the differences. Okay, look at that differences, what will happen, because I don't know whether you are understand or not. So yes, understanding or not? The creating files. Okay, I creating a file. This is o file 1 file, which is a original file. Control D. Now check it. Cat o file 1. Line is there. Very good. ln hyphen s o file 1 s file 1. Look at guys, s file 1 is not created earlier. You know, sometimes people will put they will create s file 1, they try to link it. Don't do it. So when you are creating a soft link, then only automatically a soft link file will be created. There is a lot of things are there. Okay, soft link file is created. Now I'm going to create hard link file. Hard link file don't have any option. Soft link file having a hyphen s option is there. So both are created. Soft link file and hard link file is created. Now ls space hyphen il question mark file 1. As I said, G file 1 is also come up, so don't worry, but it limits the output. See, only these files I want to see it. So as for that, I am seeing. Okay, so easy. As only one line extra, no problem. O file 1, S file 1, hardlink file, softlink file. Can you see this? This is called a inode value. I will explain inode value also. But look at this number. That's it. The number is same, and it's a link counter. It is a link counter. You can see the link counter also. And this is the last modification date. You can see the last modification date also same. This is size of the file is showing 34. This is the size of the file is 6. See it is size is not same. And it is showing L. L represent link. L represent link. S file 1 is having a arrow mark towards O file 1. Meaning is S file 1 is link file to O file 1. Soft link file to O file 1. Okay, so this is, so now cat O file 1, cat H file 1, cat S file 1. See, 3 files contain same data. 3 files contains same data. Okay. For example, you want to add something to S file 1. So double greater means append. I put a, this is S file 1 file, which is soft link file. Okay, whatever it is, control D. Now again, check it. S file 1 showing old data as well as new one, new line. H file 1. H file 1 also having the same data as the S file 1. O file 1 contains same data as a old file. And now I am again adding a lines to H file 1, double greater appending manner. H file 1 I'm adding a something like a, so you know this is H file 1 file, it is a hard link file. Anything you can add it, any line you can add it, sample. So don't put a like this, don't put like this kind of stuff, guys. Okay. Now I can see O file 1, see 3 lines are there. Yes, H file 1, 3 lines are there. S file 1, 3 lines are there. So data in the 3 files are same. Original file, hard link file, soft link file. Data is the same. Okay, data is same. Now here it is. The size of the O file 1 is become 102. Okay, 102 size is increased, and H file 1 is also increased. But O file 1 still showing 6 only as earlier. Okay, so 6 only. So the size of the S file 1 is not increasing. It is like a soft link file. Inode number is same for O file 1 and H file 1, and inode number is different to the S file 1. S file 1. Okay, like this. I don't put everything same, or you want. Okay, so just I'm putting here, but I don't want anything from there. Okay, so just for an explanation, I need this thing. Okay, so just for understanding, so like this. Okay. First of all, original file, hardlink file, softlink file. original, not file, original, hardlink and softlink. Hardlink is like a duplicate. Link is there. Softlink is like a shortcut. Link is there. You can have a same data. Data is same for softlink and hardlink and all. Size is same as a original file. But it is different. Only it shows whether it is 6K or not. So you can try how to check the size. Du as file 1 0 it is showing. No problem. So du space -h, or you can use -k. It is so some byte size is also there. 6 bytes. 6 bytes. Okay. H file 1 byte size. Sorry. Yes, file 1. B means bytes. 6 bytes. Same. Original file size increase. Size also increase. Won't increase. Same size it maintain. How much it is? 6 bytes. General I'm telling. Sometimes it may different, but general it is 6 times. Okay. Maintain same inode. I will explain inode again. Same inode. Will get different inode table number. Okay, this is inode. It is inode number. Okay, inode number. Now, last modification date is also different. Last modification also different. Last modification is also different. See, it is showing here also like this. 1204. This is 1203. This is 1204. Only showing. Okay. 1204. 1204 only. It's like a modification date also not changing. Last modified. For original and hardlink. Okay, last modify date. Same for original and hardlink file. Friend. Softlink. For softlink and them as when it is created. It is created. So that is also important point. So we can't able to write like this. That's why I've written. Guys, hardlink file is like a duplicate file, but with link. Softlink file is like a shortcut link. So data is same. Same means data inside a data is same for both softlink file, hardlink file. You can access the data, same data you can able to access. Size is same for both original file and hardlink file. Size is same, but size is different. It's always like this shortcut difference. Shortcut file size only. Size increases. Size increases in a original file. Also it increases hardlink file. but same size as earlier. Softlink, same inode number, same inode number will maintain. The last one. Okay. Last one is if original file deleted, original file is deleted, hardlink file it remains in the system accessible. It remains and accessible, but softlink file is not like that. It is invalid. It is invalid. Original data is deleted. The shortlink data you can't able to access, right? For example, I have a lot of shortcuts on my system. I uninstall that related application or a data. The shortcut still shows like this. If I'm trying to open, it shows original data is not there. Do you want me to delete? Like that. Okay, so that is invalid. So guys, we have checked already. Data is same for a original file or a hard link file, already checked. Size is also we checked it. So you can see same data for a soft link file, hard link file, and original files are maintaining same data. Next. Okay, if you are check it, size of the original file and hard link file is same. Okay, last modification date is same. Soft link file size is 6 bytes like that only, and last modified as of starting it is created, that date only it is showing. And also there is a mark like a link, it is look like this one, link. Okay, so that is soft link file, and soft link file is put a mark, arrow mark, that is this soft link file is belongs to O file 1. Okay, so S file 1 is belongs to O file 1. Inode value is also same for original file and hard link file, but for soft link file it is little different. Okay, the last statement is, what is the last statement? It is the original file and hard link files. Original file is deleted, hard link file is still accessible. Soft link file become invalid. How to delete a file? What is the command to delete the file? rm filename. Now I delete my original file. Now O file 1 is gone, H file 1 is there, S file 1 is there. If you look at the difference here, it's become black, red color kind of stuff. Okay. Now check it. Cat O file 1. O file 1 is not there. Cat H file 1. Data is there. Cat S file 1. No such a file or directory. It is showing in the list, but no data inside because of original file is deleted and shortcut file become invalid or not an existed, not a existing one. So that is why it is invalid or not accessible. Invalid or not accessible. Or we can say deleted. You can directly say deleted. Original file deleted, soft link file no use. No use. It is invalid, not accessible or deleted. But hard link file is like a duplicate file. It still remains same data. Okay. Original file, hard link file are a same data, same size it will occupy. Same is like a duplicate in another replica. Duplicate or a replica. Okay. Guys, understand soft link file, hard link file differences?
Yes, sir. Yes, sir.
So this is not required again. So I deleted a file. Then I check it, file is deleted, and what are the things which is happened, you can see. Okay. But what is this inode value? So because of when it is links files come up, inode value will be into the notable inode. So guys, I will try to understand. This is Linux is a kind of file system. In Windows, we don't know what is there, what is this one. Like if some names we know how to use kind of stuff is there. But in Linux is everything is a file. Remember guys, Linux, everything is a file only. You have a hard disk is a file. You have a CD-ROM, it is a file. You have a keyboard, that is also a file. Like that, everything is a file. You have a directory for Linux, that is also a file only. Name is directory, it's only it will maintain the hierarchy part. Okay, so whatever it is in our system, you have a different block of storage space is there. One of the important block is a data block. Actually, I have to tell 1, 2, 3, 4, but I'm telling from bottom. So this is a data block. Originally, the data block contains data. Originally, the data stores original data. Actually, we have a file or you have a directory, you have a something. Whatever it is, I said, it is the information or data is there. Whatever the data is there, the data stores in a data block. On top of the data block, we have an inode block. Inode block. Okay, there is a lot of blocks are there, but a few only we'll discuss. The first block is boot block. Boot block. What is a boot block? Contains a bootable related files. Boot sequence files or bootable files, graph related files are there. Their data stores in data block, but files information, bootable files information store in a boot block. Like that, several blocks are there, super block, boot block, data block, like that. So there is a several blocks are there. So super block is also there. But out of that one, so I want to go with the inode block and data block. Only inode block is for me important. Inode block, as I said, inode block meaning is file or a folder. Everything is a file. So first point is in Linux, everything is file. Everything is a file only. So every file, information, not data, information about information is stored in inode tables. Inode tables. Each one having a table. Each table has a number called node table number. Okay, each table having a table number. So what is that information? Inode table contains information of a file. The information is like a file name. It contains a file name, contains file name, permissions, okay, access permissions, user ID, group ID, okay, read, write, execute permissions, Okay, read and write execute permissions, user ID, prime owner. User ID means it is owner of the file. Group ID, group ownership is there. Size, file creation, modified, last modified, size of the file, created a file, last modified, created or last modified. Size is there, file size is there, when it is created, when it is modified. Okay. What is the size of the file when it is created, when is last modified? I'm trying to recollect things. Okay. Link count, link count. Okay. So file size, link count. Okay. Any other permissions related sticky kind of stuff is also there. Okay. Okay. Means any ACL, any access control list kind of stuff, means like NTFS permission type is also there. Location, of course, location of the file. Data block information. Okay, so where data block means where the data is stored. Okay, data block information where the block is stored. Here it is. This is an inode table. Okay, this is my inode table. So where these inode tables are stored? Under inode block. Each inode table having a number, a specific number is there, right? For example, this one only 4366. Okay. So what is the file name? O file 1. Okay, O file 1. Who is the user? User ID or user name? Okay, who is the user? Student 17A. So maybe it is like a 1000. User ID, group ID. Okay, user ID, group ID, or user name, group name. Size 102, for example. Size is 102. Last modified 0 to 05. And time period, for example, 1225. That is last modified. Okay. Permissions, anybody having a permissions, access, link counter, two links are there. Permissions are there, RW, R, read, write, execute, read, write, read permissions are there. Location is there, so where it is located. Okay, under /home/ student 17A. So like that, you have a information. So a lot of information is there. So I am not writing everything. So guys, understand? I know table means the table has a number. This table belongs to a file. The file contains file related information, and also data stores in data block. Okay, data stores in data block like this. Okay, so the data block ID. Okay, so data block ID. Okay, data block ID. Okay, So very simple guys, what inode contains. This is the inode number. Inode number contains permissions, username, group name, file size, last modification date, and a file name. Very simple. If you know what is this output, you can easily understand. Of course, there is some more information is there, like a Z information, like a SC Linux information also there. But that much it is difficult. SC Linux data. So guys, this is the inode value. What is inode? Inode block or inode table. Inode table contains everything about your file size, file permissions, user ID, group ID, last modified, size of the file, link and the link counters. Okay, access permissions. This information stores in inode tables. Data stored in the any file stores in the data block. Okay, like okay. If you don't understand what is this data block and all, just try to understand inode table. Okay, guys, understand inode table, soft link, and hard link.
Yes, sir.
Soft link and hard link, soft link, hard link, and original file. Original file data is we can access from hardlink file and softlink file. Hardlink file is a duplicate file. Like a duplicate file, softlink file is like a shortcut file. If you delete a original file, data remains in the hardlink file and softlink file is useless or invalid or not accessible or deleted. Okay. Inode value for original and hard link file is same. Size of the file is also same for a original file and hard link file. Size of the file is same and inode value is also same. If you delete a original file, hard link files will be accessible. Okay. Soft link file, the size does not matter. It will always maintain the same constant size like a 6 bytes. It won't increase nor decrease the file size because of it does not store any data. The data stores in original file only. Okay, and inode value is same for a hard link file and a original file. It different from soft link file. So what is the inode value? Inode value is nothing but a it contains information about the file. Okay, so information about the file is like a permissions, user IDs, group IDs, last modified, size of the file, and any other access permissions, data block information. Okay, so now it is 12:33, no problem. Next one we'll see the redirection, guys. Take another 10 minutes break, relax, and we'll start. Okay, because it's again theory practical type. Time taken for digestion, so that's why I'm giving 10 minutes time. Don't be late much. Okay, so 10, 12:45. Take a 10 minutes break.